what x value would not be a solution to the inequality? So I'm looking for y being 1. Here's y being 1. Okay? This is 1. So anything in the shade, it's not going to work. But I can come all the way over here. Look, all the way. Right here. This is not a part of it. So negative 9. That's not in there. I drew that line out there to touch it. So I can say negative 9. 1 is not a solution. Here, I'm sure that negative, 15? 1 not a solution because of how this is coming, how the slope is right there. Okay? Or the steepness of that line. So negative 9. Negative 9, 1 is explain why the point is not a solution. Negative 9, 1 is not a solution because it is not in the shaded region of that inequality. So guys, you probably say, Missy, man, you're talking really fast. Will you slow down? Keep in mind that this is a video, and you can feel free to pause this video, rewind it, and all of that sweet stuff, okay? So make sure you do that. On the back side of the paper, we're continuing with the graphing. Oh my gosh, do you notice that? They don't have, it didn't solve it for y. It's got a standard form, so I need to solve that for y first. So what I'm going to do here, I'm going to rewrite this as 2x plus 3y is less than 12. I need to get y by itself. Now, we went over through the overview how to isolate the y to get it into the slope-intercept form, so that's what we're going to do here. We're going to get rid of the mx term first by subtracting 2x from both sides. Okay? These are added to inverse, so the sum is 0. Bring down your y term. Bring down your inequality. Here, write the mx term first, which is negative 2x plus 12. Okay? Then divide each size or terms by the coefficient of y, which is 3, each term. 3 divided by 3 is positive 1, so that means y, 1y is less than negative 2/3 x plus 12 divided by 3, which is 4. Okay. Now make sure that your fractions are simplified. You could put them in a calculator. It is simplified for you. Okay. So here we go. That was pretty easy because we didn't divide by any negative numbers, so that's good. So here we go. So let's graph this. Since I solved for y, I can just put it in the calculator, and it's going to graph the shaded region for me just as well. But one thing I could do, I know that my y-intercept is 4. Okay, so I can come over here, go to y, on the y-axis, go to 4. And so I got here 0, 4 for this point. So I know it's going through that. Another thing that I know is that this is going to be a dotted line. Okay, so that's going to be a dotted line. Okay. Although, yes, I'm putting a calculator, but I still need to have an idea what is what, okay? You need to have an idea how it's going to look. And since it's negative, I know it's going to decrease from left to right. So now put it in the calculator, go to the home screen. And that's there. I'm going to start over. I'm starting over because you can get in the habit of know when you're at the new document. No, you don't want to save it. Add graph. Some of you may know other ways to do it. Feel free to do it. Okay. Then I want it to be less than, so I'm going to delete the equals. Go to the second option, which is less than. Enter in negative. Press the negative key, which is right here. Then I will put there 2 divided by 3. Then put my x variable plus 4. And press enter. And it shades it for us. And you see it went through that 4. It went through the y-intercept. Okay. And then just now we can sketch it. You probably say, what is the x-intercept here? Right here, it looks like it's, what's this, 1, 2, 3, 4, 5, 6. Okay, so that looks like a 6 there for us. Okay, which it is, it's a 6. So put my dot here. And then I'm going to sketch my dotted line. And remember, it was shaded below. It was shaded below. So let's go ahead and sketch this dotted line here. Bam, bam. Got it? And it was dotted, so remember what I do. I go back and use my eraser and make my dash. It's not dotted. And remember, we are shading below the line. And I know yours is going to look so much neater with your artistic self with the pencil and your coloring. Good. Good job. So we have it shaded. So it said the point, they left the x and y empty. It's not a solution to this inequality because it is on the line. So you can choose anything on the line and put it there. Here with the y-intercept, I can choose 0, comma 4. That's the y-intercept. It's on the line. It's not a solution because the line is dotting. Anything on the line is not a part of the solution. Here I can use the x-intercept. And the x-intercept in this case is 6, comma 0. Okay. Anything on this line will work for that, for this blank here. So that was number 3. Number 4, it's not in the y. The y is not by itself, so I need to isolate the y. So here we go. Let me rewrite this here. 3x minus y is less than equals to 6. Okay. So now this is the tricky part. What I would tell people, if you, since you have a negative here, I want to move it. I'm going to move this so I can make it positive, and you'll see why. I'm going to add y to both sides. And I know y'all said, why are you moving the y? No, let me stick to it. I'll stick to it. Never mind. Because I want to keep the same routine. Move the x term, guys. You're right. Let's do the x term first. So I'm going to subtract 3x from both sides. This cancels out because it goes to 0. Bring down my negative 1y. Negative y less than equals to, write my mx term first, negative 3x plus 6. Y is not by itself because it has a negative 1 for the coefficient. So I'm going to divide both sides by negative 1. Okay. Now, when we do this, when we divide or multiply an inequality by negative, this sign here will switch. Okay. So this sign here, I'm going to bring it down. It's going to become greater than or equals to, because you're multiplied by the negative, so it automatically switches. Okay. So now here, this become a positive y, because that cancel the negative ones. The negative 3 divided by negative 3 is a positive 3x. Positive 6 divided by negative 1 is negative 6. Okay. So here, my y-intercept is negative 6. So I'm going to go here, and I'm going to put a dot, a point, on negative 6. Okay. Then I'm going to graph it. And I know this is going to be is it solid or dotted? You're right. It's going to be a solid line. Okay. Solid line. Okay. So here we go. Let's graph this. Go to the home. New document. No, I don't want to save it. Add graph. Then I want greater than equals to. I don't want y equals. So I'm going to delete the equals to. It gives me an option. I'm going to go down to option 5, which is greater than equals to. Press enter. And it changes to y greater than equals to for me. Enter in 3x minus 6. And I'm going to press enter. And it graphs it for me. Notice it went through negative 6 here. The y-intercept is negative 6. And you notice here that our x-intercept is 2. Okay. So, and let me see, the x-intercept, it is 2. So here is my x. Yeah, and you see I put it on 3? Yeah. X-intercept is 2. All I need is 2 points to graph a line. 2 points. At least 2 points to graph a line. So it's solid. Bam, bam. Sketch that line. Put the arrows, and remember, it was shaded on this side of the line. So I'm going to go ahead and shade that. God, this shading is something. When I was your age, it was different shading because I had that number 2 wood pencil, and I just shaded it. Be so perfect and pretty. Okay, so here we go. So we have that shaded. It says here, the question is the origin a solution? Basically, is the origin on the line? So I'm annotating this. That basically says, is the origin on the line? Okay, since it's solid, or in the shaded area? That's what that means. That's what it means for annotation. Is the origin a solution? Is the origin on the line? Is the origin on the line? Or is the origin in the shaded area? That's what they're asking me. So I'm going to go and find the origin. Here's the origin. That's the origin. Yes, the origin is the solution. Why? Rewind the video. Got you. Okay. So you rewind the video to explain why or why not. Okay. So here we go. Going to the next. Let me turn my paper over. Okay. Going to number 5. Number 5. Y is not by itself. We need to get Y by itself and get the X term on the other side. So what are we going to do? We're going to go here. We're going to say Y minus 4X. Yeah, I'm about to say, you know what? I don't want to write that there. I'm going to write it down here. Y minus 4X is greater than 0.